So far in this module, we tried understanding the information related to the time complexity analysis of an algorithm, right? Now in this video, let's just try to dive into understanding the space complexity analysis of an algorithm. So what exactly space complexity analysis of an algorithm? What is the definition of it? So the definition of time complexity analysis of an algorithm is defined as, calculating the amount of memory consumed by the program to give the end result. So that's the definition of a space complexity analysis. In the case of time complexity analysis, we defined it as the amount of time taken by the algorithm to give the end result, right? Here the space complexity is defined as the amount of memory consumed by the implementation that we did to give the end result. So that is nothing but the space complexity analysis of the algorithm. Okay, so that is what the definition of space complexity of a algorithm we define as. Now the important thing that we have to remember whenever we talk about the space complexity analysis of an algorithm, right, it is completely dependent on the compiler and the programming language that we are using. Why? Because whatever the programming language that we are using, right, whatever the data types that we have, whatever the internal structures we have inside the programming language and its respective compiler, they will be different for different languages. For example, if I use Java for implementation, integer might take 4 bytes of memory. For some other language, the integer value might be given 8 bytes of memory. So the most important thing that you have to remember with respect to space complexity analysis of an algorithm is it is completely different for different compilers and the different programming languages that we are going to implement our implementations in. Okay, so that is something that you have to remember. But nonetheless, whatever the process that we follow for calculating the space complexity, right, that will still remain same. So let me just explain it by using a small example here. So let's just assume that I have written one function called find root. Okay, this function basically takes 2 points A and B and it will try to give the appropriate route from point A to point B. So I must have written some logic inside this function which will basically give me a list of coordinates that I should follow for reaching from point A to point B. In this, the space complexity is nothing but whatever is the total amount of memory that this function is going to consume. Okay, don't worry at this point of time. Again, in the next steps, I will be doing the space complexity analysis on some programs which will give you much more clarity on how we actually calculate the space complexity. And we will only use big O notation here as well. Okay, but the space complexity of this find root function is nothing but the total amount of memory consumed by this find root function to give me the list of coordinates based on the implementation that I have here. So in this implementation, I might have taken the consideration of weather conditions, I might have taken the condition of traffic. There could be a lot of other factors which could be impacting the implementation that I have taken, right? So how much memory I am going to consume to give the end result? End result is nothing but giving the list of coordinates that I should follow for reaching the point B. So that's what is space complexity of an algorithm is. Now, whatever the point A and point B that we are taking, right, these points might be of different data types, right? So if I use Java, the space complexity will be different. If I use Python, the space complexity will be different. If I use JavaScript, the space complexity might be different because they have their own independent compilers. They have their own way of assigning the memory to variables and internal processes. That's the reason why the total amount of memory consumed by the program is going to be different in the different implementation. Okay, so that is something that you have to remember all the time. So whatever the space complexity analysis that I am doing, I am not going to explain it by keeping a specific programming language in my mind. Rather, I will try to explain the procedures so that any person, whoever is using whatever the programming language of their choice, can follow for calculating the space complexity of the implementation that they are doing. Okay, so that is something that you have to remember. As part of the space complexity, we will consider the total amount of memory consumed by the algorithm as well as the input variables. What do I mean by that is, here for the find root function, the variables are nothing but point A and point B. Okay, so those are the input variables. and the memory consumed by the algorithm is nothing but whatever the variable declarations that we have done inside the function, and whatever the loops that we have initiated, whatever the external functions that we have called, whatever the memory that is consumed by those functions, that is nothing but the memory consumed by the specific algorithm. But as part of the space complexity, we will consider the amount consumed by the variables as well as the internal implementation that we are doing. Okay, so that is the basic information that you should be knowing on what exactly is a space complexity and some of the important pointers that you have to know in terms of understanding the space complexity of an algorithm. Now that we know the basic information of what space complexity analysis is, let's just try to derive the space complexity of the sample programs that I have here, and let's just try to analyze what could be the space complexity analysis of this using the big O notation. For that, let me just change my pen color here. Now, as part of the space complexity, what I mentioned, we will calculate the total memory consumed by the algorithm, right? Here, if you see, we have variables A and B. First of all, we are writing one function called multiply. It will take two numbers A and B, and it is creating a variable called result, and it is multiplying and it is assigning the multiplied result to a new variable result. In the end, we are printing the result and we are stopping the execution there only. Now, as part of the space complexity, technically speaking, we will try to calculate the total memory consumed by this multiply function, which is nothing but the total amount of memory including the variables that we have got along with the implementation that we have done inside the function. Okay, so here A and B are two numbers, right? So like I mentioned previously, I'm not going to explain it specific to a specific programming language. So I am going to assume that whatever the programming language that I am using will assign 4 bytes of memory for integer values. So based on the programming language that you are using, based on the memory that is given for the integer values, you can calculate the same thing. So here we have a variables A and B in the multiply function, right? Since both of them are integers, I am assuming that whatever the programming language that I am using will take the 4 bytes of memory for integer value. Similarly, B also, since it is an integer, it will also take 4 bytes of memory only. So overall for A and B, we have consumed 8 bytes of memory. Okay, so after that, whatever the multiplied result that we got after multiplying A with B, we are assigning it to another result variable. So obviously it is also an integer variable. That's why whatever the result variable that we are using, it will also consume 4 bytes of memory only. As a result, so far 8 plus 4. So we have consumed total of 12 bytes of memory. After that, we are simply printing the result and we are stopping the execution, right? This print function also, anyway, internally it will not take any arguments. It will simply log the value whatever we are passing, right? That's why it will anyway not consume any extra memory. As a result, the total amount of memory consumed by the multiply function that we have written here is consuming a total of 12 bytes of memory. So using the big O notation, since it is a number, what we can say is it is going to take constant amount of memory. As a result, we will represent it as order of 1, okay, or big O of 1. If we want to use the words to express the space complexity, we will say it as, it is going to take the constant amount of memory for the execution, because all the variables that we are using, we are not creating some n number of variables based on the size of the values that we are getting or whatever. Since A, B and result, 3 of them are integer values, and based on the programming language that I am using, I am assuming that my programming language is going to assign 4 bytes of memory for integer values. As a result, if I sum up all the memory that I am consuming, I have got a 12 bytes of memory for getting the end result in the multiply function. Okay, that's the reason why the space complexity of my implementation is 1, which is nothing but constant. Okay, so that is in terms of space complexity of the multiply function. Let's look at the one more example that we have here. Here we have one more function which is nothing but print array values. As part of this print array values, we are taking an array of values or nothing but list of some values that we have got in the function argument. After that, we are calculating the length of that array that we have got. Immediately we are iterating over the loop and we are printing it, and we are stopping the execution then and there only. So here, if you remember the space complexity analysis definition that I have mentioned, we will be considering the memory for the input variables as well as the memory for the internal implementation that we are doing. Since obviously it is an array, right? I am assuming that all this array contains only integer values. So in the worst case, we could have n number of integer values, right? So ultimately the total amount of memory required for this array is, let's just say we have n number of elements and each value requires 4 bytes, right? So the total memory required for this array is nothing but 4n bytes of memory. Okay, so far we have done with the arguments that we have got for the function. Now internally we are calculating the length of the array, right? Length of the array is nothing but an integer. That's the reason why this assigning calculating length, since it is an integer, it will take 4 bytes of memory again. Internally after that, we are defining a for loop. Inside the for loop, we are defining a variable I, and I also, if you see, we are starting from 0 and executing till last index we have in the array, which is nothing but, again, since it is an integer, it is also going to take 4 bytes of memory. Anyway, print function will not consume any memory, right? Because internally it will not declare any variable or anything, it will simply print the value. Now if I sum up all the memory that I've consumed here, it will be 4n plus 4 for variable declaration n and another 4 bytes of memory for I variable declaration. As a result, the total memory will be 4n plus 8. So whatever the rules that we have followed for time complexity analysis, right, where we neglect all the constants associated to higher order terms and all the lower order terms we will neglect, right? So we will follow the same pattern here as well. As a result, we will neglect this plus 8 and we will neglect this 4 also. As a result, the space complexity of the implementation that we have here is order of n. Okay, so that is the space complexity analysis of the algorithm that we have here.